So before we get into the technical details of things, the exciting part about 3D printing is talking about what unique needs a 3D printed object can fill for a student. The intro mentioned it's the future of AT, and I really believe that. Computer and tablet operating systems are getting better and better built-in accessibility supports, but that still leaves us with unique needs to fill when it comes to those needs to help with activity of daily living tasks, durable and tactile communication systems, or physical access to tools and the environment. A 3D printer helps us custom make tools to fill students' unique needs. Some of the items we'll look at today might be available for purchase through a vendor, but you can't ask most vendors to make something in a different size or a different color or with a different texture. You're stuck with their design. With a 3D printer, the sky's the limit. You can meet the exact needs of your students. If you're not familiar with 3D printing, the idea of designing something yourself can be a little overwhelming, but thank goodness, other people have already created some templates that we can just customize. So we'll take a look at that. But before we dive into those, just in general, I want to talk about our learning targets. And so the idea isn't that you're going to necessarily memorize all these things, but you will gain experience with all of this. And the resources within the slides here, you can use at any time to refresh your memory in the future. So you're going to learn where to find pre-made templates so that you don't have to custom create everything from the beginning. You can just modify something to meet your students' needs. And number 2 there, you'll learn the process for acquiring a 3D printed object at 917. And number 3, you're going to learn how to customize a pre-made grid. So first you're going to learn how to find those pre-made templates, and then you'll learn how to customize them. And number 4, just want you to have a basic understanding of operating the 3D printer. Now, if you're someone who feels like they will use that 3D printer regularly, like you want to be able to actually hook your computer up to the printer, then you'll want to pay close attention during that part. If you are just someone who's going to design things and send them to me to print, then you can just have a real basic understanding of how that 3D printer operates so that we can collaborate about the best way to print the object that you've sent me. All right, let's keep going here. So we're talking about ideas and some places to find ready-to-print templates. And Thingiverse is probably the most common, probably the biggest one out there. It's not designed specifically for the special education world, but that's okay. Lots of people still use it for that. And so you will be able to find some things out there on Thingiverse. And here in black, there's just a bunch of terminology in case as you're going through the Thingiverse website, you're wondering what all these particular things mean. But that's Thingiverse. It's to find ready-to-print templates. If you find something you like, you can bring it into a program called TINKERCAD. Now, TINKERCAD is very, very basic designing. It was actually designed to be kid-friendly. It's just shape-based, so you're either building up something or you're making holes in something. And so there is kind of limited advanced design, but the nice thing about TINKERCAD is you can change the size of objects really easily, and often that is one of the only things that we need to do is to make something a little bigger for a student or make it a little smaller or add a little bit more security to something a built-up handle or something so that the student can use it better. So that's TinkerCAD. TinkerCAD, you can find things that other people have already made, and you can customize things within TinkerCAD. And if we keep going here, wanted to also point out that the Project Core website has some amazing 3D printed core word symbols. And so these are meant to be the universal, so used by everyone. If a student is using these symbols in one district, hopefully when they go to another district, that district will have the same set of symbols, or at least can print them out, which is really nice. So we want to keep those consistent if you go out and print something from the Project Core website. And then the last resource I wanted to point out is the atmakers.org. So atmakers has these whole guides and files, and they are designed specifically around meeting unique needs of students. So they'll have things like switches and switch mounting. And so they're a really nice place to look into as well. So I want us to go out and take a look at Thingiverse here a minute, so that you can see how you might be able to find something and then bring it into TinkerCAD and change it, and then send it to someone to have printed. So I'm just gonna go to Thingiverse here. And it really is as easy as just searching for what you would like. So let's just go out here and type in the word tactile books, because I happen to know that there are several in Thingiverse. So here we go, and some of these we're going to get exactly what we wanted, and some are going to be a little bit different. But if I wanted to print this tactile book, I'm just going to click on that thumbnail there. And now I can say download all files. And now sometimes you'll just have one file here, and sometimes you'll have several. You can see here that we have one file for each page of this book. So let's just go ahead and download just one so you can see how that works. And you'll see it's going to automatically download as an STL file. And that is the file that works with a 3D printer. So you're not going to print anything that isn't in that STL file format. So now that we have that object, it might be that we want to change it. Maybe a student needs that page of that book to be a little bit bigger. So now we can go to TinkerCAD. Now both Thingiverse and TinkerCAD are free. If you're not going to save anything within Thingiverse, you don't even have to create an account. TinkerCAD you will want to create an account in, however, because you're likely going to be using it to work on some of these objects. And so it's free, both of them are free. Just go ahead and sign up with your email address. But now I'm in TinkerCAD, and again, if I wanted to find something that someone else had made in TinkerCAD, I could go up to the top by my little icon here, and I could just search. So I could put something else in here to search for. But if I want to go back home, I'm gonna click the blocks up here in the upper left, and I want to create a new design using that book that I just downloaded from Thingiverse. Now I want to import that book, the page of that book anyways, so I'm going to hit import. And now I can choose a file, or I can drag and drop one in there. I'm going to drag and drop. And now you can change the size right away. using this scale here. So maybe I just need to make this 125%, or maybe I need to make it twice as big, 200%. Whatever you want, you can put in there. The other thing that is sometimes helpful is to change the millimeters here to inches, just because that's how most of us are used to measuring things, is in inches. But once you have that, you can just hit import. It will take a few seconds to bring that file into the work area here. Okay, so this looks a little strange when it comes in, but nonetheless, this is the page of our book. We've already made it a little bit bigger. We did that when we imported it. But if we wanted to add anything here, just want to show you real quick how easy it is to do that. Maybe the student needs some text up in the corner to know what page they're on. There's a little text box here where you could add that. It might be the student needs a little tab sticking out here so that they can turn the page a little bit easier. Let's go ahead and do that. So we're just going to grab one of the shapes from over here on the right. We're going to slide it on over. And then we can just kind of push and pull this shape until it's how we want it. And the color really does not matter one bit at this point, because the color just depends on what color filament you have in the printer. So we want to make this a little bit shorter, so we can click on all of these until we can find the one that's going to shrink things down. And so again, like I said, you can drag these, or you can actually click inside there and change the size that way. So let's change this down to a 5.0. And maybe we change this one to a 1.0. And then we can kind of turn it around. Okay, so there's our little tab around the outside of this page. And so now what we need to do is we need to group this tab. Anything you add, you're going to have to group together so that it prints as one thing. So I have my little tab selected. So now on my computer, I'm going to hold down the control key while I also select the page here. And then I'm going to go up here and I'm going to say group. So now all those things are grouped together, and now I can export this file. This file is essentially ready now to be sent to the printer. I'm just going to say export, and I'm going to be sure again that I choose the STL file, and it's going to export it for me. And that file is the one that I might attach to an email to send to someone to print. Or if I'm printing from my own computer, I would send that to the MAKERBOT software to print. You can see that it gives it a really strange, unique name, TINKERCAD does. So obviously you can go ahead and change that. We just want maybe say revised page. Because if I look in my file and I see Swanky Amberus, I'm not sure I'm going to know what on earth that is. So there's a little bit about Thingiverse, a little bit about TINKERCAD. And so let's go back to our slideshow here. There was Thingiverse, there's our TINKERCAD. If you want to know more about the ins and outs of using TINKERCAD, there's some tutorials here. It won't take you long to learn, to go through. I think if you go through all these tutorials, I think it's a total of 10 minutes. And then you'll really understand what you can do with TINKERCAD. So again, Project Core is pretty easy. Just click on the link here and you'll be taken to the list of all those core words. And it's also going to explain to you how to get started using those tactile symbols for communication. And so it talks about using these 3 symbols to introduce the words go, not, and like, and get really good at those 3 symbols before you move on to introducing any more. So that's Project Core. AT makers, you could really spend lots of time diving into this site, but this link will take you directly to the guides. And so you can take a minute and read through these. But so here they're going to show you how to make a hand raiser light. So for those students who can't raise their hand, they use some 3D printing and then some other tools to create that hand raiser light. So these are pretty cool. Again, you'll just click, they'll have an additional link at each of these where they'll walk through all the steps to create that, as well as have those files in there that you'll need to send to the 3D printer. So that's AT Makers. Now, I just want to show you some of our favorite things that we've made or found here at 917. This first, so I've done little training sessions with our OTs and PTs, our speech therapists, our deaf and hard of hearing teachers, and our blind visually impaired teachers, and our physical health disabilities teachers. And so I just want to go through and show you some of the favorite things that each of those groups have found, because they might be helpful for you as well. One here was a customized spoon that we actually made. There is a nice deep dish there on the spoon, deep scoop, as well as a built-up handle. So we have a customized spoon. We have a cup holder here for laundry detergent. So this for a student who has a hard time holding the cup with one hand and pouring with another, they can put the cup right in there. And then we have a chapsticks holder here. So if the student has trouble holding chapsticks and that's something that's important for them to do, they can use this little guy. The chopsticks go in the end of his feet here. The other way I know our OTs are using it is just for fine motor activities. So if you're using chopsticks to work on fine motor skills, this would be one way for students to hold on to that. And then we had created a customized key for a game. So if you have a piece from a game that doesn't work for a student, maybe they need a bigger piece to hold on to here, or maybe you've lost a part to a game, you could certainly recreate that. So those were the things that are, some things that our OTs and PTs were excited about. Our speech therapists also were excited about some things like the tactile emotions book. You know, often we need durable books, we need durable communication symbols, stuff that doesn't rip, stuff that's waterproof, and that's what both the emotions book and the core word book offers. And obviously besides that, they're accessible to students who are blind or who have low vision. The other thing to be excited about is the ability to customize AAC device keyboard, or key guards, for different page layouts. And sometimes there might even be something on the page that you want to hide from a student. And if you can't use the communication software to hide those things, you could cover it with a piece of a customized key guard. You could use the key guard to cover part of it. And then we have a whisper phone here. And of course we could buy these somewhere, but by 3D printing it, it gives us the ability to customize the size of it. So you can really customize that along with the color of the phone, You could add some text along the phone, anything that might help motivate a student to use it. So next up, we have some things that our teachers for students who are blind or who have visual impairments were excited about. And one was this Braille Writer Finger Guide. So you can see this is just going to help students who are learning to write Braille and using that Braille writer. It's going to show them proper finger placement. So it has these little ledges in here for students to know, okay, this is where my fingers need to rest. So that has been helpful. And then there are some Braille spelling puzzles. So it's hard to tell from this picture, but each of these pieces has Braille letters on it, and all together they spell the word rocket. And so there is a line down here to indicate that this is the bottom. And then you have the R-O-C-K-E-T. And students would just use those and build the rocket. There is one puzzle available for each letter of the alphabet. So that was a really good find. And then we created just a tactile thumbs up and another one for thumbs down to help with communication. And then our physical health disabilities teachers have enjoyed customizing pencil grips, because we know not all fingers are the same shape and size, and some of our students needed things that were spaced differently than the pencil grips that you get at the store, or they needed them smaller. So that worked well, along with using TINKERCAD to create some name or even just some word plates of sight words and stuff. And so the text here is big enough for the student to put their pencil in and use as a guide, and just helpful for those students who are not steady enough with a pencil to handwrite those on their own. Just gives them a little bit more support. And then again, our PhD teachers were excited about the idea of key guards, but this time more for creating them specifically for using different apps on the iPad that students are using. So you could have a key guard that's just going to help students target specific areas of the screen within different apps that they're using. So that was nice. And then our teachers for students who are deaf and hard of hearing, they enjoyed having some ear models so that students could practice putting in ear molds. This is helpful because practicing doing that on yourself is hard because you can't see your own ear. And obviously practicing on someone else is a little awkward. And then they also enjoyed printing out some cochlear implants and hearing aids for toys. You know, if your doll has one, have those pieces. You might be more apt to wear one yourself. So that was an interesting find there. And then the third thing on there is just a model of the inner part of the ear, because a 2D model of this just doesn't offer the same level of understanding, right? You can't see exactly how all those pieces overlap and necessarily how they connect. So having that 3D model has been helpful. So that's just a real brief overview of the sorts of things we've been printing, but we do have a document out there that you can also access with links directly to a bunch of 3D printed objects that have been favorites within 917 here. And if you find something that you would like to add to this, please feel free to do that. Okay, so next we want to get into a few details about the 3D printer that we're using in the district. So what we have is the MAKERBOT Replicator Plus. And I mentioned before, it's capable of printing those STL files. And it's housed at CEC. So that's where you're going to find it. We don't typically move it from building to building just because it's big and a little bit fragile. But you are welcome to come to CEC. If you have something that you want to watch being printed, I could do a Google Meet with you so that maybe your students are excited about seeing the 3D printer in action. We could do a Google Meet so that they can watch it. But yep, that's where it's housed right now. And just wanted to talk about the printer terminology in general. So you might hear or read some of these terms as you're searching for 3D objects to print. So the filament, I want to make sure you understand what that is. So that is the material that's used to build the 3D printed parts. So it comes on a reel, and then what happens is there is an extruder here, which you really can't see in this picture, but the extruder heats up that filament, and then the carriage here takes that extruder, that hot glue gun, and moves it back and forth until your object is printed. The build plate is obviously the place where you're going to build the thing that you're making. It's important to note if you're working with the printer that you don't touch that build plate with your fingers, just because you're going to leave behind some oil residue, and then the next thing that's printed isn't going to stick to that build plate. So just something to keep in mind if you're there watching that, watching something be printed. A little bit more terminology. When you first start printing something, it's going to put a string of filament across the build plate. That's called your purge line. So if you see that happen, don't worry, that's normal. That's what it's supposed to do. PLA is the kind of filament that we use, and it is non-toxic. So that's also important. No one's going to get sick if they eat some of it. Now that doesn't mean that they won't choke on something. So you do have to be mindful of that, but it is non-toxic. It's a video about the MAKERBOT print software. So again, if you are someone who's going to be hooking your computer up to the printer, you probably want to watch that video because it's going to give you some more details about what to do there. But if we keep going here, we're going to go through some printing tips. And on this slide here is the link to the actual MAKERBOT print software. So again, this is free. You will have to create an account just in order to sign up for the cloud services. But again, download this if you want to be the one printing from your computer. So when you open up your MAKERBOT print software, it's going to look like this. And if you want to adjust some settings, maybe you want to make whatever your object is really strong, because maybe you're making a ramp for a wheelchair and you want to make sure it stands up. There is this settings icon right there below the little I. And once you open that up, there are some options here, but there are even more options if you click down into custom settings. So let's look at those custom settings. So here is where you can really make some changes to what you're printing, and the things that you would change primarily would be if you're trying to make something really strong, you can increase the number of shells that you use. So the shells are just going to be the outside of that object that you're printing. The other way you can make it stronger is to increase the infill percentage. And you maybe saw on the slide earlier that even that making that infill any higher than 60% really doesn't make it much stronger, believe it or not. And as far as shells go, If you get up to 5 or 6 shells, that's really the maximum you're ever going to need. So you can go in here and adjust the shells and infill. The other thing that you are likely to change in here might be your base layer. So if you are making something like those key guards, those are really flat and thin, and they're large and thin. And so usually by default, what the printer is going to put down first is what's called a raft as a base layer. And that just gives the rest of your object something to stick onto. So it's going to just put a real thin layer of the filament down. Well, if you have something that's large and flat, for your base layer, probably what you're going to want to do instead is what's called a padded base. And a padded base will just help keep the ends from curling better. So those are some of the print settings that you may decide to adjust. I guess the other thing I could mention here is if you are just printing a prototype and you don't care about how strong something is, you could either go over here and do a draft. So that means there's hardly, it's going to be more hollow, a draft would. And if, you know, maybe you're doing something really large, you could do something that's minimum fill, and then it's going to be really, really hollow. So balanced is kind of, it's going to use the most filament and be the strongest, especially if you adjust your shells and infill. And then draft is kind of middle, and min fill is the minimum fill in order to make something. So those are some other settings that you might be interested in. Now if we just look at the printer controls, this is the front of the MAKERBOT replicator. And if the MAKERBOT happens to be off, you're just going to use the top button there to turn it on. The knob over here is going to scroll through all your choices on the screen. And then if you press that knob in, you will select the choice that it's on. So if I would press the knob in now, it would print because that's what's chosen over here. So changing filament, just some notes about changing the filament. The filament is essentially glued into the extruder when it's cooled. So you must follow the on-screen instructions for changing the filament. So you have to use that control panel that you just saw, and you have to choose to unload the filament, because what that'll do is it'll heat it up, and that makes it safe to then change that roll of filament. And then when you want to put a new one in, you will choose on the screen to load the filament. And again, it just heats up the extruder and makes it ready to grab that filament and bring it into that extruder mechanism. So be sure you do that. And then there's a level on that filament drawer, and that's meant to be pushed, not pulled, in order to open the drawer. We'll give you a little bit of a video here too about changing the filament, just so you feel more comfortable. So to change filament on our 3D printer, we're going to start by choosing filament on the screen here. And we'll do that by moving the knob. And then we're going to press the knob to select filament. And the first thing we have to do is unload the filament that's currently in there. And that's our top choice there. So we can press the button. And now the 3D printer is going to heat up that filament so that it can release it. It will tell us when it's all done and ready to be taken out. So we'll just be patient while it's heating up. So you can see that the printer spit out the filament tubing here along with some of the filament, and as soon as you see the message, that says unloading complete. You can now pull that out the rest of the way. And if you look over here, we're going to push this down and pull the filament drawer up. And now we can just take this reel of filament and move it clockwise so that it's gathering all the filament here. Okay, and then we push these together and we can pull this off. And now we're ready to put our new reel of filament on. And so let's grab a different color. And you can see the difference here. This is the front of the filament, and this is the back of the filament reel. So we want to be seeing more of the filament color facing us. That's how we know we have the front. Now, once we have the reel in there, we're going to take the end of the filament and we're going to feed it up through here. If the filament doesn't guide through there easily, if it feels like it's getting stuck, you're going to want to turn the printer around and take a look at the back here. You can see that the tubing up here is out of place a little bit. So we're just going to have to hold that tubing into place while we thread the filament up in there. Once you have it in there that far, you can turn the printer around and you can continue to feed that filament from the front. And you want to keep feeding that filament until you see it come out of the tubing here, and then keep going until you have at least probably 4 inches coming out of the bottom of the tubing there. And then you want to go back to your screen and you want to choose to load the filament. So you're going to use your knob and go down to load this time and press the knob to select load. And now that smart extruder needs to be heated up again. So we'll wait for that to happen. Once the extruder has heated up, you'll get a new message on the screen telling you to push the filament into the extruder until you feel it being pulled in, and then you're going to keep loading the filament until you see it extruding from the bottom. So we're going to go up here and we're just going to put this end in there, and now it doesn't take very long until I can feel it being pulled in there. So you'll see some filament has extruded from the extruder top up there, and we can just take that filament away. Then we just want to go up, back up to the filament drawer, push the drawer down, and now we're ready to print. So we're just going to tap that top button to go back to the main menu and turn our knob so that it's ready to print. And now we can send our file and print in our new color. Another thing to know about filament is you can pause printing at any time while you're printing your object and then change the filament in the middle in order to add a different color. So it might be you want some contrast on whatever it is you're printing. So you can certainly do that. So you can do that just manually by hitting pause on the printer itself, or you can program in a pause as you're printing. All right, so now it's your turn. Let's do it. Time for you to find something to print, customize something to print, or create something from scratch to print. And so here's just kind of the brief process for doing that. You're going to use, and these are all active links, so you can use Thingiverse to find a project. You can use Project Core to find a project. You can use the AT Makers website to find an object. And you can use TINKERCAD to find an object and to create or customize an object. So those 3 or 4 things there will get you started. And once you have what you want, you're going to export that file into an STL format. Then you can email the file to me. Be sure you tell me what color you want me to print it in, and any other special printing instructions, like, you know, this doesn't need to be strong, or maybe it does need to be strong. Let me know about that. Your other option is you can stop by room 208 at Concord and send the file to the printer yourself by hooking up your computer to it. And then once your file's printed, I will send that object to you via interdistrict mail when it's all done. So if you're not sure yet where to start, but you want to use what you've learned here today, an easy place to start would be to click down here on this TINKERCAD keyring letters lesson. So you're essentially making a keychain that has letters on it, but the lesson is also walking you through how to use TINKERCAD, and it'll give you a real good sense of what you can do with the program and might give you some ideas about what you want to do in order to create something for your students. All right, so I hope we've hit our learning target and you have a better idea of how you can use a 3D printer to meet the unique needs of your students. And then using these slides as a guide, remember, you don't need to memorize all these things, but using the slides, you should be able to list the resources to find pre-made templates for printing, list the process to acquire an object that you want printed. You should be able to understand how to customize pre-made templates, and then understand the basics of operating the 3D printer. And that's something that I realize you're not going to be super comfortable with until you've done it at least once. And so by all means, the first time you want to hook up your computer to that printer, let me know and we can make some arrangements to do that together so that you really feel comfortable using it and we keep that printer safe. All right, well, thank you for listening. Please let me know if you have any questions or you want any help getting started. Take care. Have a great day.